Have you ever stopped and thought about how much information, like, just comes at us every single day? It's crazy. I mean, between like the internet, our phones, everything, it's like we're drowning in data.
Yeah, it's a fire hose.
Right. So what if instead of all that raw data, we could just get the core meaning, cut through the noise?
That's the whole idea behind semantic communication.
It sounds kind of like magic. Like, how is that even possible?
Well, get this. Scientists are actually using light to transmit meaning. Not just data, but actual concepts.
Wait, hold up. Light can carry meaning now.
It can.
Hold
And
up.
we've got this super fascinating article from Light, Science and Applications that details a major breakthrough in this area.
So we're not talking about like Morse code with flashlights here. This is something totally different.
Totally.
Right?
This is about encoding information into different frequencies of light. Like, imagine giving each concept its own color.
Whoa. Okay, that's pretty wild. But how does that even work? I mean, how do you send meaning with light?
It all starts with something called multimode fiber, or MMF. Yeah, basically think of it like fiber optic cables, but on steroids. They can transmit light in multiple modes, different pathways, and by encoding information into different frequencies of light within those pathways, they're able to achieve a 7-fold increase in capacity compared to traditional methods.
7 times. That's a huge jump. But I'm still a little lost on how the meaning part works. I mean, you said it's like giving each concept its own color.
Right. So think about it like this. The concept of happy could be represented by one specific frequency of light, and then sad would be a slightly different frequency.
So instead of transmitting a bunch of data to describe, say, a picture of a cat, you'd just send a signal that means cat.
Exactly. You're sending the concept itself, not the raw data.
That is so cool. But, okay, what's the real advantage here? I mean, besides just speed, what makes semantic communication so much better?
Well, it's not just about speed. It's about efficiency and robustness, too. You see, by only transmitting the essential meaning, you cut down on all that unnecessary data that clogs up our networks.
So it's like getting to the point of a conversation without all the extra fluff.
Yeah, exactly. And because you're only sending the core meaning, the transmission becomes much more robust. Even if part of the signal gets lost or distorted, the core concept can still get through.
That's pretty impressive. So even with like a noisy signal, you could still understand the message.
Right. It's like, when you're talking to someone in a crowded room and you might miss a few words, but you can still get the gist of what they're saying.
Yeah, I totally get that. But, okay, how do we know this actually works? Like, did the researchers actually test this technology out?
Oh, they did. And they chose a really interesting application to test it out on. Sentiment analysis.
Sentiment analysis. Okay, what's that?
Well, basically, they took a bunch of movie reviews and they encoded similar sentiments into nearby frequencies.
Hold on. So they were trying to see if the light could understand whether a review was positive or negative.
Exactly.
That's crazy. So what happened? Did it work?
The results were actually remarkable. They found that the system could accurately gauge the sentiment of a review, even when there were errors in the transmission.
Wow. So the light was actually able to understand the emotion behind the words.
In a way, yes.
That is wild. I'm starting to see how this technology could be used for so much more than just sending data faster.
Oh, absolutely.
What other possibilities are out there? Like, what else could this be used for?
Well, the potential applications are huge. For instance, just imagine a world where communication is so secure that it's practically impossible to intercept.
Because the message is literally encoded in the meaning itself.
Exactly. It's like a whole new level of security.
Okay, so we've got light carrying actual meaning. It's going through these super-powered fiber optic cables. But I gotta admit, I'm still a bit fuzzy on how it all works on the other end. Like, you said the meaning is encoded in the frequency of the light, right?
Right.
But how does the receiver actually, decode that information?
Well, it all comes down to this thing called intermodal dispersion. Remember how we were talking about MMF having multiple pathways for light to travel through? So each frequency of light representing a different concept, they travel at slightly different speeds through those pathways.
Wait, hold on. Different speeds? Wouldn't that, just scramble the message?
See, that's the really brilliant part. They're actually using that dispersion to their advantage.
Okay.
Because each frequency travels at a slightly different speed. They arrive at the receiver at slightly different times. And that creates a unique pattern.
So it's like each concept has its own arrival time, like a code.
Exactly. It's a code. The receiver analyzes those arrival times, and then it can decode the original message based on that specific pattern of frequencies.
It's kind of like how our ears can distinguish different musical notes based on their frequency, right?
Yeah, there you go. That's a great analogy.
That's pretty amazing. So we've got the speed, the efficiency, the robustness, and now we've got this super clever way to encode the meaning itself. It's really like a whole new way of thinking about communication.
It really is a paradigm shift.
So where do we go from here? I mean, what kind of crazy things could we do with this technology?
Oh, the possibilities are, they're mind-boggling.
Like what? Give me an example.
Okay, well, imagine, being able to interface with technology using, just our thoughts.
Whoa, hold on. You're saying we could control computers with our minds?
Well, think about it. Instead of typing commands or talking to some voice assistant, we could communicate our intentions directly.
By translating our thoughts into light frequencies.
Exactly.
Okay, that sounds pretty sci-fi, but I could see how it's possible. I mean, theoretically. But realistically, what kind of hurdles would we need to overcome to actually make this, a reality?
Well, there are definitely challenges. A big one is, figuring out how to encode and decode these complex meanings efficiently and reliably.
So we'd need algorithms that could accurately map human concepts to specific frequencies of light.
Yeah, and vice versa.
And what about the processing power? It seems like you'd need some seriously powerful computers to handle all of that.
Right. That's another area where there's a lot of research happening right now. We need to develop hardware that can keep up with the speed and the complexity of semantic communication.
Mm-hmm.
But the progress that we're seeing in areas like photonics and AI, it's very promising.
Okay, so let's talk about security for a second. You mentioned earlier that semantic communication could be, incredibly secure because you're not sending the actual data itself.
Right.
But couldn't someone still try to intercept the light signal? Couldn't they try to, decode the meaning?
That's a valid concern. But because the meaning is encoded in this really complex interplay of frequencies and arrival times, it's way more difficult to decode than a traditional transmission.
So it's more like trying to break a code, not just eavesdropping.
Exactly. Plus, remember, semantic communication is very efficient. So you're actually sending less data overall, which means there's less for a potential attacker to try and grab.
So it's like a win-win for security. You're transmitting less data, and it's harder to decode in the first place.
Right.
So this is all really fascinating stuff, but where do you see this technology going in the future? What are the next steps?
Well, the research is still pretty early, but the potential is huge. We need to keep refining those encoding and decoding algorithms. We need more sophisticated ways to handle complex concepts. And then, of course, we need to keep exploring all the potential applications.
Right now we've been talking about, data transmission. But what about things like healthcare or education?
Exactly.
Those are areas that could really benefit from this kind of technology.
Oh, absolutely. Think about transmitting complex medical data or creating these really immersive learning experiences.
It's like we could create this global brain, right? Where everyone can contribute to and benefit from this huge pool of shared knowledge.
Yeah, it's an amazing concept. And, beyond those practical applications, there are these philosophical questions that this technology really raises.
Yeah, we touched on that a little bit earlier, but I'm still trying to wrap my head around it. If we can encode meaning into light, does that mean that meaning itself is a fundamental property of the universe?
That's a big question, Philosophers have been debating the nature of information and meaning for centuries.
Is it something that we humans just create?
Right.
Or is it something that exists independently of us?
And now we have this technology that suggests that maybe, meaning can actually be woven into the fabric of reality itself.
It's like we're blurring the lines between the physical and the abstract. It's pretty mind-blowing. But it also makes me wonder about, the potential downsides.
No, for sure.
What are the risks we should be thinking about?
That's such an important question. Any powerful tool can be misused, right? So we have to be really mindful of the potential for things like, manipulation of information, or even unintended biases that could be baked into those encoding algorithms.
So it's not just about the technology itself, it's about the ethical framework that we build around it.
Exactly. We need to be having these conversations about the impact of this technology on society. Who controls the flow of meaning? How do we ensure equitable access? These are questions that we need to be thinking about now, before this technology becomes widespread.
So it's like a call to action for all of us. We need to stay informed and engaged and, help shape the future of this technology.
I think so.
Because the future of communication and maybe even our understanding of the universe is kind of, in our hands now. Welcome back to the deep dive. We've been talking about semantic communication, where light can actually carry meaning, and it's pretty mind-blowing stuff. But I'm thinking, what's the big picture here? How could this technology actually impact, our everyday lives?
Well, that's what's so exciting about this. I mean, the possibilities are just huge, really. It could touch pretty much every aspect of our world.
Okay, so give me some concrete examples. What are some of the areas where this could be, a real game changer?
Let's start with healthcare. One of the biggest problems we have in healthcare is just the sheer volume of data. We're talking about medical images, patient monitoring data, genomic information, all this stuff.
Yeah, and it's only going to get, more and more as technology advances.
Right, exactly. But now imagine a world where we can transmit all that data super fast and super accurately using semantic communication.
So things like telemedicine and remote surgery could become, way more effective.
Absolutely. And it goes even further than that. We could even start developing entirely new diagnostic tools.
You mean using light to analyze medical images and identify things that, a doctor might miss?
Exactly. The potential for earlier, more accurate diagnoses, it's enormous. And, healthcare isn't the only area where this could be a game changer. What about education?
Okay, yeah. How would this work in education?
Imagine students being able to learn complex concepts by, literally downloading the core understanding straight into their brains.
I mean, that sounds a little like, science fiction, but I get what you're saying. In a much more efficient and intuitive way of learning.
Right. And we could even create these super immersive learning experiences. We could personalize them to, each student's needs and learning styles. And then, of course, there's scientific research.
Yeah. How would semantic communication impact research?
Well, think about it. If scientists can easily share huge data sets and complex models, it could really speed up the pace of discovery.
It's like creating this global brain, where everyone can contribute to and benefit from this massive pool of knowledge.
Yeah, exactly. We could solve problems so much faster. And honestly, those are just a few examples. We could talk about finance, transportation, entertainment. I mean, you name it.
It really does feel like, the possibilities are endless. But I want to go back to something you mentioned earlier, this idea that maybe meaning itself is a fundamental property of the universe.
Right.
I mean, it's a pretty big concept to wrap your head around, right?
For sure. Philosophers have been debating this stuff for centuries. Is meaning something that we humans create and impose on the world?
Mm-hmm.
Or is it something that's already out there, independent of us?
And now we have this technology that seems to be saying that meaning can be, built into the fabric of reality itself.
It's a pretty amazing thought.
Yeah, it is. But it also makes me think about, the potential downsides, the risks. I mean, any technology this powerful could be misused.
Well, absolutely. That's why we need to be having these conversations. We have to be aware of the possibility of things like manipulation of information, or even those unintended biases that could get baked into the algorithms.
So it's not just about, the technology itself, it's about the ethics.
Exactly.
Yeah.
We need to think about things like, who controls the flow of meaning? How do we ensure that everyone has access to this knowledge? These are big questions.
And we need to find answers, before this technology becomes mainstream. It's a call to action for all of us, really. Stay informed, be part of the conversation, and help shape the future.
The future of communication, and maybe even our understanding of the universe.
And who knows what other incredible discoveries are out there, just waiting for us to find them. For The Deep Dive, I'm your host. Thanks for joining us, and we'll catch you next time.